I just change it.
Should I just go to the 4.11?
No, no, it's yeah, just little bit slow actually.
Can go to 4.11.
Yeah,
Takes a while actually. That's okay. I'll do my intro by that time. Hello, welcome again. Uh, for those who haven't met me, my name is Abhijit Mugali. I'm the product manager for TDM. So I have been with this product since almost the inception, back from the grid tool days. So probably I can name, like you, all the different names over the years. So when we were collecting feedback on this particular conference, right, one of the topics which came up pretty much in every comment was that, what are you doing for AI and ML? And as such, we have been doing several things on AI and ML. So I wanted to sort of grab like 10 minutes of the presentation just to specifically talk about the work which we are doing in AI and ML. So just to kind of level set, we are right now on TDM 4.11 release. We went GA in Feb of this year. And with each release, we have a small set of themes where we tend to focus and expand the functionality on those areas. So in 4.11, it was usability. Usability has multiple facets. One of the things which we are noticing is that TDM has become a discipline of niche to a discipline which is done across the enterprise. And hence it's paramount to have like good usability for the product. So this release, we moved completely to a new UI framework called React. So that gives you better controls, better filters, VPAT capability. But we also re-engineered some of our core workflows, and specifically scan, mask, and audit, because we have noticed that customers want to essentially get a handle on the PII in their non-prod environments, remediate using masking, and then continuously audit it to demonstrate compliance, right? The other area is around scalability, specifically masking scalability. So just as an example of the scale our customers are undertaking, I work with a very large Canadian financial institution, very similar to the organizations you represent. And just like 3 or 4 years back, they were masking around 300 million rows of data, few applications in a year, right? And today they are masking like 400 billion rows, right? That's almost like they are growing like triple digit every year. And hence we essentially developed this functionality which can scale horizontally, but more importantly, it can do the masking within the maintenance window. So we have had like customers who mask like billions of rows of Oracle data in less than 3 to 4 hours, right? So that's the power this gives. And as enterprises and our customers are investing on data science teams, we are similarly expanding our footprint to cover these newer technologies. 4.11 was specifically MongoDB, Cassandra, and BigQuery, right? So that's where we are right now. What we are working on right now is 4.11 plus. And 4.11 plus is primarily around synthetic data. How can we redefine the synthetic data using AI and ML? I'll talk more about it in the couple of slides later. Associated with it is also the configuration deployment, because we have seen that customers want to essentially apply best practices from one part of the organizations to the other. So things like exporting rules, configurations can be done by one team or learned by one team and essentially applied to others. So that's what this helps. And again, there is a continued focus on your technology, be it Apache Parquet or Azure Synapse, and expanded support for Hadoop High. So before I talk about AI and ML, we started this exercise probably year and a half back. So what you see on your screen is essentially a typical workflow which is used by majority of our customers. So on the left, you have the production or the snapshot of the production, and then you apply TDM disciplines. Maybe you'll do a data discovery to build your logical model. Maybe you do a PII audit. Then you would do TDM activities like subsetting, masking to create a gold copy. Once you have a gold copy of the data, then typically you tend to push down to multiple application teams where they can augment additional data using synthetic data generation or do further selective subsets and expose it through self-service types, which are end user portals. So we looked at each of these and said that where can AI and ML be a disruptor? And we have identified like 5 areas, and we are proactively working on each one of them. So starting with synthetic data generation, because this seemed like a low-hanging fruit because of two reasons we did this. One is we have algorithms available which can generate synthetic data, right? Also, synthetic data is becoming increasingly important from a compliance standpoint. In fact, in certain geographies, you're getting regulations that if a data is super sensitive, you can't even mask it because it has some ties to the production and it can be reverse engineered back to it, right? But I'll talk more about the synthetic data generation in the coming slides. But what we want to do there is to leverage algorithms like generative adversarial networks as well as some of the natural language processing. Sorry, there is a bit of AI and ML jargon here, but I'll try to simplify it as we go through it. Then the next is subset. Subset is a discipline where you have a large amount of data, but then you need to reduce it to a smaller referentially intact set. So go from 1 billion customer records to, let's say, 100 million, but still have the relationships so that it can be used for testing, right? So herein we could apply like a lot of AI and ML, including sampling. There is k-means sampling, which can provide a great sample without the need to do manual configuration. Other area is differential privacy. This is a discipline of AI and ML where you introduce random data in a very statistical fashion so that you can't judge whether it's real data which has been derived from the production or it is like fake data, right? So you can't essentially trace back to the production. The interesting bit about this is that there is evolving standards around it. Think of it when encryption came in and AES 256 became a gold standard. Similarly, there are active standards being developed for differential privacy. And this allows you to just build a model on top of production, but be really safe that whatever you're querying out is still non-PII, right? A couple of other areas are around PII detection. This is to kind of find the needle in the haystack because the data is spread across multitude of data sources. So AI and ML techniques can help us to uncover that. And finally, all of this would lead to data chatbots, which would leverage one or more of these to essentially get the data in a very natural language. So what we are currently working with is around AI and ML synthetic data generation. So while the slide comes up, right, the problem statement today is that synthetic data is very promising, right? However, it is very labor intensive. think if you think back, right, what you do in synthetic data is you write a function for each column of each table, right? So if you want to generate a name, you write a function. If you want to generate a date of birth, you write a function, so on and so forth, right? So it produces great data. It gives you very good coverage. It's better than getting ton of data from the production. It can give you all of the edge case scenarios. In fact, a lot of our customers are using it to test the models for future scenarios, but it is very labor intensive. What we are trying to do as part of this exercise is to reduce the amount of rules which you need to write by 95%. So only less than 5% of the columns will need data rules to be explicitly written, but then rest of it is auto generated, right? So we have been working on three areas which I'll just cover in this slide. The first approach, which we almost finished the proof of concept, is around using data generation models, AI and ML data generation models. And there is a wide gambit of models available out there, but we chose two. One is called as a generative adversarial network. It's a neural network wherein like there are two models. One is a generator, one is a discriminator. And both of them feed off each other, right? So the generator tries to generate data and the discriminator tries to discriminate whether it's the generated data or the original data. And it gives you that feedback loop. And at the end of it, there is a convergence wherein it's undistinguishable from a statistical point of view what data it is, right? So that's one approach. The other approach, which is very interesting for us, is the transformer based architecture, because this allows you to capture relationships not only between like columns in a row, but also between rows and also between tables. So it can provide you much more, uh, not only referentially intact data, but the context of the data is not very much changed. However, some of the cons around this approach is it's very resource intensive. It requires GPUs to train. When we put it against our customer data, we ran off the GPU budget for the entire year just to train one model. So it's very resource intensive. And hence, we are also looking at the second approach, right? However, it's very still promising. We are working on optimizations to make it work. But the other approach which we are also looking at is called as a data assistant. So like I said, synthetic data generation is all about writing functions, right? And the question came in like why AI and ML cannot write functions. And that's what this is about, right? First part is like the algorithm looks at the name of the column, the data there, the distribution, the tags associated with it, and and picks an optimum function to essentially uh, generate the data for it. Also, one of the interesting things we are building into this is the ability to clone data. Typically, when you start doing synthetic data generation, and this is true for very legacy system, you don't know what exactly is a logic of a particular column, right? Because it was done like years back and you don't know that, right? So what clone allows you to do is not really bother about the logic. It looks like this data is used for some aspect. I don't know what it is. I'll just move it here. I'll not even bother about writing a function to it. And based on these two functions, right, what tends to happen is that you can generate very high quality synthetic data. The biggest advantage of this is that it doesn't require GPUs to train. You can essentially have like an algorithm which is CPU based, not requiring large amount of resources. So this is the last slide. One of the things which came up when we were doing this is that we wanted to do a better PII detection. today our PII detection is based on classifier packs, which are manual rules, right? However, these rules do not account for the needle in the haystack, and that's where the PII data escapes. So we have been using and doing R&D on based on libraries like Spacey, which essentially utilize something called as word vectors to scan through the data and essentially get to it. But also we recognize that the customers themselves have like a lot of rules, and this library has the great capability to add those rules and not just work on a static model. I know we are running out of time, but just to kind of wrap up, right? We are investing like ton of money on this particular area. In fact, I would say 60% of 4.11 plus release is primarily around AI and ML. And if any of your organizations are interested in participating in betas and trying out this functionality, more than happy to have you engaged and share with what we are doing. With that, thank you so much for your time, and we'll open up for any final questions.
One question, like as you are mentioning about, we are quite bullish with respect to Gen AI and working towards LLM. So the kind of data which TTM is generating, like do we have any feature that we can convert that into respective embeddings and put it into the vector DBs and all that stuff? So that kind of feature is we are targeting.
Uh,
That
in terms
ready-made
of
embeddings can be a very powerful thing. So that, yeah.
essentially utilize the generated, when you say embedded to a vector database.
Yeah, like if we are talking about Gen AI or Open
Hmm.
AI, so we have a vector DB, like
Yep.
where all the data like
Yep.
LLM models are converted to
Yep.
embeddings. That
Yep.
embeddings goes to vector DB, and
Yep.
from there we are like
Yeah,
putting a,
we
yeah.
have some customers who do that specifically when they want to have the data to train the model and look at the behavior for things like biases, future scenario modeling, those kind of things. But they use utilities slightly outside of it, but they leverage some of our workflows engines called as Javelin, which are like very much optimized for like data movement to do that. I guess that's a wrap. So, is it a break time now?
It is break time.
Oh,
You wanna announce
awesome.
Okay, so you've got a 15-minute break. So we'll meet back here. I guess the time? It will meet here at 2:40. Oh, it's 2:40 now. So we will meet here, I guess 55, right? So there we can show you where the tea and coffee is if anyone wants to go. I'm sure one of us can show you where it is. There's water here. There's bathrooms on the right. And I'll be bringing some just candies and things to the table, and you guys can chat, and we'll be around.
All right. So In the next 1 hour, I'll be covering service virtualization. So, quick introduction about myself. I'm Deepak Dinasi. I'm a solutions engineer at Broadcom. And the roadmap, I'll be covering about 2 use cases. Post that, we'll have a roadmap session covered by Beverly. Right? So, before getting into, here's a quick agenda. Oh, this goes a little slow. Before getting into the, so here's a quick agenda, service virtualization overview. Use case 1 regarding cloud migration, how you can deploy SV on Kubernetes, right? Then I'll be talking about APIs, how you can deploy, leverage the APIs of SV. And then we'll get into the roadmap session, what you can expect in the near future. Right? Again, let's make it a little interactive. Please stop me anytime during the presentation, any questions you have during the demo. Right? Let's have an interactive session. So before I start, anybody wants to take this question? What is service virtualization? Have you heard that term, service virtualization? All right. What is it? Anybody? Right. Simulate the behavior. There you go. So service virtualization is a process where you simulate the behavior of your endpoints, of your dependent system, so that you can give a constraint-free environment to your developers, to your testers. A lot of times in testing and development, a lot of constraints, they will face. For example, if they are developing an application that talks to a mainframe, right? You need to have access to the mainframe, which will be pretty expensive for the MIPS, right? Or if you want to make a backend call to a payment gateway system, right? They charge you, right? For testing purposes, that's $1, for your organization, right? So in those cases, what happens is service virtualization virtualizes these backend components, be it a mainframe, be it an application server, be it a middleware application, be it a queue, MQs, right? So all these systems gets virtualized, and instead of having these expensive, huge infra that you need to run these real systems, that gets replaced by our thick, very, very thin virtual services, which behaves just like a dependent system, just like a real system is, right? So you have at the front end, you have your different applications that you're running on your mobile, on your web browser, right? Trying to test the application. And these applications make a backend call, right? Be it your mainframe systems, your SAP middleware systems, databases, third-party APIs, right? Service virtualization sits right in between, understands the transaction that happens between your front end and your back end, and it records that transaction. And when the back end is not available or it's not ready yet, it plays back. It mimics the same behavior, the same response that a back end, that a real system would, right? That is service virtualization for you, right? So where do we use it? We have different use cases. You use it in integration testing. You use it in performance testing, right? You use it in development, right? So integration testing, if you want to integrate different systems, right? Sometimes Team A has finished their development. Team B is still, still in the development stages. So how will you test whatever Team A has developed, right? You use service virtualization. You virtualize the Team B dependent application so that you can continue testing your Team A, whatever application they have built. Performance testing, right? A lot of times, when do you generally do performance testing in your organization?
Is going to prod.
Just before it's going to prod, right? Towards probably the later half of the SDLC, right? So what service virtualization gives you is the power to do performance testing even when the single line of code is written, you can do a performance testing. Just to give you a visualization, like I have an automobile, a car, right? A lot of times we do the testing on the engine, the transmission, all the different systems. But we go to the nut and bolt, that holds the automobile. So what service virtualization does is it virtualizes your car so that you can do a performance testing on the nut and bolt and make sure that doesn't break. Because if that breaks, it will have a ripple effect on your application, right? So that's the power of service virtualization where in performance testing, you can shift left your performance testing, right? And of course, development, right? Developers use that. And the benefit of having SV is it improves the quality of your product. The application product that comes out, from your QA will have much better quality. Right? There are a lot of use cases of service virtualization. I have just listed a few of them here. Again, this is not a exhaustive list where you can use service virtualization, but just to name a few, for example, here mainframe, right? Mainframe is one of the biggest constraints we see customers facing because they have to pay for the MIPS, right? They are charged for the MIPS that they have whenever they connect to the mainframe systems. Service virtualization can help you there. It can virtualize your mainframe systems so that you can continue your testing purpose. Third-party API calls, payment gateway that I spoke about, right? Your performance constraints, negative scenarios. A lot of times whenever an application is up and running, more often than not we see the positive scenario. You log in, generally login works, right? You make a transaction, a payment transaction, generally it works. But I want to test negative. What happens when the login has alphanumeric as opposed to just alpha, or just numeric, right? How does that combination work, right? Service virtualization helps you do those kind of testing. Chaos testing, right? I'm in the middle of making a payment transaction or making a money transfer. What happens if my service just goes out, right? What happens if I create a chaos in my application testing? Service virtualization helps you in the chaos testing as well, right? So these are some of the use cases where we have seen customers leverage SV, but there might be a whole bunch of them. Okay, yeah, go ahead. Okay, so the question is, does it mimic the mainframe or act as a in-between layer? So what happens is, you visualize SV as an agent which sits on your LPAR, right? And all the transaction that comes through your, the caller to the mainframe goes through the kicks to your different LPARs. It understands, it's like a middleman. It's seeing all the, like a gateway. It's seeing all the transactions that's happening, the request that is coming, the response the mainframe is giving, and it is learning. It is understanding that. Now the mainframe you take away, you replace it with the virtual service, it will respond back to the application just like a mainframe would. Very good question. So we have something called as a different invocation methods. One of them is live, meaning anything that changes in your backend, it understands that, and your virtual service will become intelligent enough to respond back to the calling application because there's a change in the backend behavior. Any behavioral changes, it understands and responds back. Sure, go ahead. Any kind, as I told you, database is one among thing. Middleware application, it can be your Kafka, your MQs, right? So it can be different protocols. We have a whole bunch of protocols that we support. So any kind of backend application call that happens, right, which has a request and a response, we can understand and replace that and play these virtual services. Okay, yeah, sure. Execution, right? Yes. All these for execution, it will learn. It will learn live invocation. All the different invocation methods. You will know. So it will learn first when there is a change in the live invocation. It will know that there is something changed in the behavior of that particular request, and it will change the model itself, saying that this is the latest behavior. New transactions. There you go. You can make it, when you're creating, basically when you're, let's say there are scenarios where it's always positive, right? So you want when there is an error, false positive, right? So basically what virtual service does is it's a request and a response. There's a model called VSM and there's a response called VSI files. So the VSI files has all the different responses. You can say that, use this response when this request comes. You still have to, if it has not recorded already, because it can only record and play back, right? Okay, so moving on. So I'll be demoing, I'll be talking about two use cases. The first use case is about how do I move service virtualization dev test onto the cloud. So today I think I heard a lot of customers are looking at leveraging the cloud, right? So how can we move service virtualization, deploy in the cloud, make it containerized based applications, right? So this use case talks about that. This demo talks about deployment in the cloud, right? So what the problem statement here is tight timelines for cloud migration, right? We need to quickly deploy virtual services in the cloud, deploy SV in the cloud, do quick testing, and then bring down the environment. Otherwise, you will be charged, the more resources you use in the cloud, right? So SV helps you to today deploy all the SV components in the cloud, right? So here you have a lot of backend servers that we see. The backend servers are probably your real servers. You may have 10, 20, 30 real servers that are responding to your requests. So what service virtualization does is, you, instead of having so many servers responding, you can have a lightweight service, virtual service, which does the exact same thing that a normal server would, right? Thereby you don't need those huge, infrastructure to do, for your testing purposes. Right? So we support most of the cloud providers, AWS, Azure, Google Cloud, your private clouds, right? So you can deploy SV, dev test on all these cloud platforms. And we do support container-based technology, Docker, Kubernetes, and OpenShift, right? So these are all the dev test components. I'm sure people who are using dev test SV will be familiar. Identity access manager, enterprise dashboard, registry, portal, virtual service environment. This is probably the most important one for your virtual service to run, right? So all these components gets transformed into pods on your, on your cloud platform, right? And the most important thing here is the configuration server. That is a pod that contains all the configuration details of your dev test architecture, all the different components. So that is the most important one. Once that pods gets up and running, then you need your IAM, right? And then your enterprise dashboard, your registry, and all the different other components of dev test that gets deployed in that order. Okay, so here's a quick deployment architecture in the cloud. So again, in my demo, I'm going to demo on GCP. Pretty similar if you are using any of your cloud providers or your private cloud as well, right? So in this, you can see all the different pods, and the most important thing is to have a database, right? Make sure when you're deploying SV on the cloud to have a either you leverage the cloud databases, or you have a VM or instance where you have your own database installed, right? So that is important because you need to persist the data. So what are the prerequisites to deploy SV on the cloud? I would probably classify them into three sections. The first one is probably the environment itself, right? So you need a Kubernetes environment, Kubernetes installed, version 1.24 or later. You need Helm. Helm is our, which helps you to install the, deploy the containers, right? 3.0 plus. And you need Docker registry. You need to have created a Docker registry, a local Docker registry, so that you can pull the images from our repository, right? So these are all from an environment perspective. Then you need a database, as I said, external database, one for IAM, one for enterprise dashboard, and one for registry, right? In my demo, what I've done is I have created a Postgres SQL database running on a VM, and then I'm deploying all the components on the cloud. And the third important thing is on the cloud provider itself. First, you need a service account, right? And this service account should have enough rights to create roles, to create tokens, which is needed during installation. Then you need to create a namespace and have a Kubernetes namespace created, Kubernetes engine created, and then you need to have some nodes defined for that Kubernetes cluster. Once that is done, then you need to create something called as a PVC, persistent volume. It's something like a mount, like your hardware that you are telling the pods to write stuff into a memory, right? So all these things are from the cloud provider perspective. Once these things are there, you are now good to go with deploying the SV on the cloud. So before I go into the demo, I just want you to visualize a very simple application called as Digital Bank. So this bank has a simple web interface, an application server, and a backend database. But for this bank to function, it needs to make a lot of API calls. For example, in this demo that I'll be showing, it is making a call to the ATM service, right? A new service was added to this bank, or a new request came to this bank saying that they need to know the different ATMs in a particular zip code, when you give a particular distance, saying in the next, in 10 miles, 5 miles, whatever, right? So this was a new service that was requested. Now, because its ATM service is a third-party service, you have, its availability is very critical. Otherwise, you really cannot test your, banking application, right? So in my demo, I'll show you how you deploy it into the cloud and how you can virtualize the ATM service. Okay. So I have a recording of this. So we'll go through this recording, and again, this will, as I told you, the first and foremost important thing is to have your service account created in any of the cloud providers. So in my demo here, I have a service account created on GCP. It can be Azure, it can be AWS, whatever, right? So in my example, I'm showing you on GCP, right? So you need to have a project and a service account created. Once that is done, then you will create a cluster, a Kubernetes cluster, and I have assigned 3 nodes to the cluster, right? So this is on the GCP side, right? Next, what I'm going to do, you need to have a storage class YAML file, right? This tells you what kind of storage you're going to have created for your dev test. So I'm using a file store. You can use SSD or whatever storage your cloud provider provides, right? Once the storage class is defined, then we create something called as a persistent volume. Again, another YAML file which you need to deploy on your on GCP, and this will tell you persisting that particular storage and bounding it to dev test namespace, right? So all the things that you do, all the configuration files that you create gets persisted. And the next thing is values.yaml file. So this is again, we will we'll share this with you, right? But you will have to customize it based on your load balancer, your cloud provider. So you can see here, this is all customized to my environment. I have my dev test registry running on a Postgres database. So you can see that it makes a JDBC call, right, at a particular IP address, right, dev test registry. So this is a configuration file that you can, configure based on your setup, right, your cloud provider, right. So you can see IAM running on that Postgres database. So there are a few things. Again, our documentation gives you enough data to help you, how to create your own customs.yaml. So in my example here, I have two two G Cloud setup, one on my Linux and one on a Windows server. On the Linux, I have my G Cloud installed so that I can run some of the Helm commands, right? Some of the kubectl commands, some of the Docker commands. So here I'm giving you a Helm command to install dev test namespace, right? And I'm saying use the customs.yaml and deploy all my containers, right? So this is now deploying all the containers on my GCP. So here I'm giving you a kubectl command to see if the pods are up and running, and you can see all the different pods that are up and running, right? Usually it takes a couple of minutes, 3 minutes before the all the pods come up. So the main thing, as I told you, configuration server, IAM, enterprise dashboard, registry, and then I have created a virtual service environment. I'm just calling it as -0. So that is the virtual service environment that I have created for this demo. Right? So once the pods are running, the next important thing is I need to know how I can externally connect to it. So I run this particular command kubectl to get the IP address. So that is the IP address of the pods, because as you know in cloud, you will have a load balancer, and you through the load balancer you go and connect to the to our portal, right, or the enterprise dashboard or your IAM, right? All the different UIs that you have, you can connect through the load balancer IP. So I'm going to use that, and I'm going to log into my portal here. Any questions? While I hope you are able to follow what is going on here so far, right? So I've now logged into the portal, and I want to see if my environment that I created, my pod is up and running. So if I go there, you can see my virtual service environment is set up, right? So this is and then you can use this typical as you normally would use a dev test. You can go create API test cases. You can create virtual services. So in my demo here, I'm just showing you, using RR pair, how you can create a virtual service to the virtual service environment I just created. Yeah. So again, going back to that ATM search, so you have positive results, service not available, 0 results. So all these scenarios, we have recorded, and I'm providing that as a request response pair, so that my virtual service knows how to respond when there is a positive, zip code coming, when there is no zip code coming, when there is a service down kind of a error, so that I can mimic all the scenarios. Okay. So yeah, I mean, this will go through just creating the virtual service. I think you are familiar with this. You can go deploy, and once you deploy, you can start, consuming the virtual service. Any questions before I go to the next use case? Save and deploy the virtual service, saving. Then you can, the virtual service is deployed. And now I can consume this particular virtual service for my testing purpose. Yeah. Any questions on that particular use case? I hope you got a context, right? How to deploy in the cloud, what are the things needed, the YAML files, the configuration, setting up the environment, prerequisites. Generally, those are the most important things. Once that is there, rest all activities just goes like a jiffy. Easily you can deploy. Yeah. Brum Broadcom. No, you'll have to pull it from our registry. So, and then you can store it locally in yours and then use it. You have to pull it from our repository. Yeah. Yeah. Okay, use case 2. In this use case 2, I'll be covering on the API part, right? So we now saw from a, from a cloud perspective, right? A lot of times what happens, developers, they would not want to look into the thick client, the UI, the portal. They would like to leverage the APIs and quickly create a virtual service, deploy a virtual service, update a virtual service. So in this demo, I'm going to see how using a pipeline, right? So you can use any of the pipelines. In my demo, I'm showing how it's done through Jenkins. I'm using Jenkins, but any of the Azure pipeline, whatever, Chef, if you have, you can use your organization standard and integrate dev test into that pipeline and automate all these activities, right? So quickly just go over few slides. So I just spoke about the problem statement, right? Developers who are looking for solutions that align to their ways of working, meaning no UI, right? So that is where API comes into picture, right? So I'll talk about what is new in this API, in version 10.7.2. So people who have used service virtualization would know that there are already a few APIs already we provide, right? Like for example, Lisa invoke, invoke to test invoke to, for the test cases. But we have recently come up with this V3 API. The advantage of V3 API is instead of having multiple steps, in the older versions of the API, this gives you in just a single command to create, deploy the virtual service, update the virtual service. Much easier and much faster for a developer to quickly test, right? What are the new things that are added in this V3 API? You can update the virtual service, right, using request response pair, a zip file pretty quickly. I'll show you in the demo. You can create using your Swagger definition files, Waddle, RAML files, right? Quickly create a virtual service, right? You can we do support multiple DPH, right? We support header, where you can match based on your request header and then send a response. That is a new feature that was added. Think time, so I'll talk about that. I'll show you a demo how you can tweak the think time during while you are testing, right, through APIs, right? And we have a Swagger UI that we expose all these. You can go to Lisa invoke API v3 Swagger-UI, and it will return either a JSON or a XML that you can use. Right? Typical use cases of APIs would be deploy virtual service, deployment of your virtual service, creation of your virtual service, using different scenarios. As I said, negative test cases. How can I test negative scenarios? Update the virtual service for that behavior. Slow responses, again, something that I'll be showing you. Today, generally, when you deploy virtual service, usually it responds in milliseconds. How can I mimic so that your network latency, so that it takes 10 seconds, 20 seconds to respond? So how does your application behave when the response becomes slow? So all these things you can mimic here, chaos testing as well. Right, this is a quick pictorial representation of the API itself. So you can go to that particular URL, and here you can see just provide the VSC name, and it gives you all the different status of the virtual service environment, whatnot. Right. Again, going back into the example of the digital bank. So I'm going to show how I will be updating the ATM search feature of this virtual service. Okay, so in my demo here, I'm using Jenkins. So again, as I said, on the Linux machine, I have my G Cloud where I deployed the primary, all the different components. Now using Jenkins on my Windows machine, I'll be connecting to the portal, and I will be deploying a new virtual service environment. So just to think about it, think of it as a new, different team who wants to deploy a virtual service environment on the cloud, deploy virtual services, and then once they are done, bring down the environment, right? So that's the use case. So here is my Jenkins pipeline. So I have split the pipelines into different things, like create additional VSE, create a virtual service, right? Now, in the first thing, I'm creating an additional VSE, the virtual service environment itself, right? So again, another YAML file, and there I have my virtual service. I have defined it as virtual service environment 1, right? I'm just calling it as 1. So what I'm doing through pipeline, leveraging the APIs of DevTest, of GCP, I am now creating an additional VSE. So instead of, in the earlier scenario, I ran a command. So all that is now done through API, right? So this will create an additional VSE on the cloud, on the DevTest namespace that I have created, in the cluster in GCP, right? So people familiar with Jenkins, you will know that you can go look at the console output, see whether it is successful or failure, and you can see it is pretty similar to the command that I ran, on the command that I gave, Helm command, very similar. So once this is done, a new additional VSE called Virtual Service Environment 1 will be created on your DevTest namespace in GCP. So usually it takes a few seconds. So you can see that, again, programmatically, we didn't have to run any commands. Programmatically, it was able to create a new virtual service environment, right? A new virtual service environment is created. I've just called it as 1 here, right? So once this environment is there, now the tester would say, I don't want to use the environment created by some other team. Let me have my own environment, right? So this is his own environment where he will deploy his virtual services, right? So again, using Jenkins, I'm now leveraging the V3 APIs of SV, and I'm going to create a virtual service using RR pair. Now, the thing to kind of note here is, this RR pair will only use a single request and a single response, meaning a ATM request where probably for a particular zip code, it will record that, and a single response will be sent, right? So that is what I'm doing. So you can see here I'm talking to get my RR pair, and then I'm making the V3 API calls here to see all the different environments, and I'm selecting the environment that I want, right? And then I'm creating the virtual service. So I'll give a build now command, and it will go ahead and build the virtual service for me. Again, you can see here that's the request 11749, radius is 10, and here is the positive response, right? So I've given a hard-coded request and a hard-coded response that I'm getting back, right? So it will go ahead and create a virtual service for me based on that particular request. When you send, it will send you that particular response. No, as I said, anything, any pipeline, any using API. Ultimately, Jenkins is also using the API, right? You can use anything. I have just used Jenkins here. All right. So here you can see once it comes up, you can see that the virtual service is deployed. But there's a disadvantage here. Can anyone guess what it is? So I'm copying that URL and I'm just uh, going to Postman, use that, send the zip code 11749 radius 10, and I'm sending the request, and I'm getting the response back, which is Islandia, country USA, pin code 11749, which is good. But what is the disadvantage of this virtual service? I really cannot test different, other zip codes, different radius, right? So that's it's constrained because of a single request response, right? So we'll see as the demo goes what happens. And the second thing is this responds in hardly a few milliseconds. What if I want to mimic a network latency? So for that, what I've done is, again, through APIs, I'm updating the think time so that my virtual service will now not respond in few milliseconds, but probably 10 seconds. So for this, what we use something called as, again, the same request response. We create something called as a meta-response.properties, and I say use think time spec as 10 seconds. So now the API, the virtual service will take 10 seconds to respond back, right? And then you can test how your application is behaving when the response is slow, right? That is called as a sidecar, and you update your virtual service using that sidecar properties file, and on demand, the virtual service will take that value and start responding slowly. So I'm mimicking a slow response. So while I'm testing my application, I'll just use this call and make the response slower. Network latency, yes. Yeah. So here you can see that it has taken about 10 seconds to respond. But still, it is still responding for that 11749, right? But what happens if I pass a different zip code? Either it gives me the meta response or not found, right? So for that, what I have done is I have created another this thing called data driven, where I am parameterizing my zip code and the radius, and I'm saying I'm sending an Excel sheet. So this Excel sheet can be created by TDM, which has all these different things, different zip codes with different, country codes, street address, whatever, right? And I'm going to use this in my, so you can see I'm using the zip.xls file, and again, I'm getting it from the Git, using the API, getting the transaction ID, which transaction ID I need to update this to, right? Getting the transaction ID from the virtual service, and then I will update that particular virtual service transaction ID with my latest data, meaning with the zip file, so that it uses the zip file data to respond back. So in this way, what happens, this becomes much more dynamic, meaning if I pass 11749, 11750, whatever is there in the Excel sheet, it uses that data and picks up that particular row records and sends the response back to the to your application. So this is data-driven virtual services, a very new feature that was added in V3, in the latest V3 API. Either CSV or a Excel file. Database directly, I think, is not possible. Is it? Any idea? VSI step. Right. Correct. Yeah. Depends on how you create the model. If your model is already created, then you can do it at the Excel file. But if you can tweak your model, it will go talk to the database and get the response. So here you can see that I'm just using different area codes, and it is responding back with different based on that particular zip code, that particular data it is responding, right? And then I'll go ahead and remove the virtual service. I've finished my testing. I'll remove the virtual service, I'll remove the virtual service environment. Thereby, I consume, some of the, resources. Right? So this is a quick demo that gives you overall what we call as ephemeral virtual services, where your virtual services exist only for a short period of time for your testing, and then you bring down the environment, thereby conserving resources and dollars for your organization. Any questions before I hand it over to Beverly for roadmap? Oh yeah, we do support recording. You can record the virtual service as is using the pipeline through APIs. You can create using RR pair for sure. Then you would have created, if you already have a.
So the recording, if you want to do a recording, is a little more complex. It's not through V3. So you do have to do all the builder session and other things and string the API calls together. So it is available through APIs, but it's not as intuitive to start the recording. However, another way to think about it is I could do something like I create an RR pair, and I also indicate where the live service is, and then I could change the execution mode to basically learn, and then I could get that into. So there's other ways, which basically kind of turns on a recorder. And that might be simpler than trying to string it together, but both are available. Just the recording in and of itself is not in V3.
Thanks, Beverly. Any other questions?
The VS, which was set up, the last point you were telling, it uses some resources. So what is like what kind of hardware it really need, or any extra storage, or
yeah, so all that will be defined in your YAML file. In the earlier thing I showed you that YAML, right? The customs.yaml. Yes. That will tell you how much resources each of these pods will take. Like you can define your CPU should take so much, your IAM will take so much memory, so much this thing. You can define that. It's configurable.
And I'd add it depends on the use case. So if you're doing a functional type testing, you probably don't need to get as much throughput through the system. So you probably don't need it. We have different kind of resources defined depending on, like, if you're bringing up a microservice and you want to performance test it, that's going to obviously, you're going to require different types of resources. So a little bit of it depends on kind of what are you doing, right? What kind of testing are you doing? And some of it depends on your application. Right? If you have, like, how big are your payloads and other types of things that are related to the virtual service itself. So we do have some best practices on that, and we can also help guide you if you want to share. We'll have some tables. We can maybe dig into your specific use case.
okay. So just trying to understand this virtualization, the purpose is to, instead of directly connecting to the server, we can fetch the data from the virtual services. So one of the purpose is to reduce the cost of directly getting into the server. Instead of that, we are connecting to the virtual service.
Directly connecting to the backend server, database, whatever. You are connecting to a virtual service and you are getting back the similar response.
Can we say that the resources we are utilizing for the virtual service is very, very lesser?
Much lesser, absolutely. Much lesser compared to a normal server. Imagine if I'm doing a mainframe testing. I have to have a mainframe environment set up for my testers and developers, right? Or take some MIPS from production mainframe.
Yes.
It's all expensive, too costly for your QA and development work. Rather, you can use these virtual services, right?
Okay.
And that much lighter, less resources intensive.
Okay.
And much easier to.
Yeah, understand. So trying to compare the resources utilized for virtual server comparatively with the maps we utilize is very less. Okay.
The other thing to consider is you can virtualize right to your downstream neighbor. So if I'm application A, and I call application B, I can virtualize right there in order to test application A. B might call C, and C might call D and E and F, right? So you can basically remove all of that, because I'm only caring right now about A, and A is just talking to B. So you can also think about there's all this other infrastructure and setup that you don't really need as application A. So one way to think about is, what am I trying to test, and what does my environment landscape look like? where do I want to put the replacement, and if everything else doesn't matter because I'm getting predictable responses. Yeah. Any other
So let's say that I have a virtual service. So when the request is received and we respond back with virtual responses, is there any way that I can store the request, whatever we received, and the response into a database? Mm. Let's say if I want to store a response, it's always stored in the database. Hmm. Yeah. Hmm. Okay. Okay. So let's say that we have a transaction count. Let's say there are 100 transaction count on a service, and if I make a change in my virtual service and redeploy it, the transaction count will be reset. Hmm. Okay. Is there option to keep it? Okay. Okay. Thank you.
I need to test application A. I have a dependency on application B, but from there, that application is not yet ready. It is still they don't have any payloads or nothing. So in that case, how we can virtualize and test the scenarios? Yeah, exactly.
If I send a request, what am I expecting? That is all defined in a contract. That contract can be your Swagger definition file, your RAML, WADL files. If you give us that, we can create a virtual service. You don't need the application B, or to record it. You don't need that. You just need that contract, and we can create a virtual service for you. Or you can even build it from scratch. Even if you don't have the contract, you can say, here is the request, let me build the response from scratch. Here's the response that I'm going to get from my application B, and then continue testing your application A.
Yeah. And one more, can we integrate TDM with SV? Can we
Oh
directly?
yeah, definitely.
We can do
So TDM can be integrated with SV. As I said in my use case, you can use TDM to create the data, and you can use SV to leverage the data created by TDM in your testing purpose. So either in the model itself, you can have a step which goes to the database, reads the record, and sends the response, or create an Excel file that you can consume.